Hello, my name is Louis Facile, and I will be teaching Laws of Logarithms. But before we do that, let's recap on the laws of exponents. In this case, a to the power of b times a to the power of c is equivalent to a to the power of b plus c. And a to the power of b divided by a to the power of c is equivalent to a to the power of b minus c. And a to the power of b to the power of c is equivalent to a to the power of b times c. So since logarithms are exponents, the law of logarithms follow the same principle. So let's see these laws. The product law of logarithms states that the logarithm of BC at base A is equivalent to the log of B plus the log of C, both with the base of A. The bases have to be the same for this to work. Same as the bases for the exponents have to be the same for this to apply. The same thing with the quotient. The log of b divided by c is equivalent to the log of b minus the log of c. As for the power, in this case, the log of the log at base A, the log of b to the power of e, in this case, not c, is equivalent to e times the log of b. So let's work on some examples. Evaluate each of the following logarithms of products. So here we have log 4 plus log 6, both by the base of 6. So we solve it based on the product law. It is equivalent to log of 4 times 9, which equals 36. And since we know that 36 is 6 squared, you can also write this as 6 squared. And based on the base of 6, since this one is also the base of 6, the answer will be the exponent part of it. In this case, 2. For the next question, the log of 8, the log at base 8 of 16 plus the log of 32, so this is equal to log of 16 times 32. And here you get, when multiplying, the log of 512. Now, in case you may not know what a to the power of equals 512, another method that you should know would be the log of 512 divided by the log of 8. When there's no base that indicates the log, that means it is automatically 10. Mean that it's 10 to the power of 8. No, it's 10 to the power of something is equal to 8. So on your calculator, When I do that, it is equal to 3. That means that 8 to the power of 3 is equal to 512. You can even check on the calculator. As you can see, it equals 512. The next question. The log of 27 plus the log of 19 at base 3. As we know now, it is equal to 27 times 9. Which makes it 243. So we're using the same method as before. The log of 243 divided by the log of 3 . Do it on the calculator. It equals 5. Okay, so for next one, evaluate each of the following logarithms of quotients. So for this section, the log of 320 minus the log of 20. That is equal, base of 2, that is equal to the log of 320 divided by 20, which is equal to the log of 16. And as we know, the log of 16 is equal to the power of 4. Therefore, the answer is 4. The next question. The log of the base 3 to the power, the log of 18 minus the log of 6, both by the base of 3. So that would be equal to the log of 18 divided by 6. And that would equal to the log of 3. So in this case, since both bases are the same, you know that 3 in this case is 3 to the power of 1. Since they're both the same base. Therefore, the answer is 1. The next question. 2 times the log of 5, the log base 5 of 15 minus the log of 9. Now before we do anything, we first have to, based on the power law, we have to move the 2 to the 15. You have to square it in this case. So then it would be the log of 15 squared minus the log of 9. So then we do 15 squared. That's equal to 225. And since we're in subtraction, the log of 5, the log base 5 of 225 divided by 9, which is equal to 25. And as we know, at base 5, it's 25 squared. That equals 25. That's 5 squared, that equals 25. Therefore, the answer is 2. Moving on. Example 3. Evaluate each of the following logarithms of powers. So in this case, we have the log base 3 of the cubic square of 9. So when converting it to a fraction, the cube root of 9 is equivalent to 9 to the power of 1 over 3. And when making these the same base, that would be 3 squared to the power of 1 over 3. Therefore, you multiply the 2 times 1 over 3, which would be equal to 2 over 3. Therefore, the answer is 2 over 3. Next question. The log of the square root of 25. So we convert that to exponents. That would be 125 to the power of 1 over 2. And in this case, we can use the other method. Or actually, we can use this one, because 5 to the power of 3 is equal to 125. So in this case, it would be 5 over 3 times 1 over 2. That would be 105. The log of 5 is equal to 5 to the power of 3 over 2. Therefore, the answer is 3 over 2. Next question. The log of 4. The log at base 4 of 1 over 16. Now remember that 1 over 16 is equivalent to 4 to the power of negative 2. Since it would be the same as saying 1 over 4 to the 4 squared. So in this case, since their bases are the same, the answer is negative 2. And all this you can just check. Yep, it's 1 over 16. Okay, the last example. Solve for x. In this case, we would solve using the laws of logarithms. You could just turn these into exponents and then calculate them. But here we'll be using laws of logarithms. The log at base 2 of x equals the log of 5 plus the log of 10. So that would be equal to the log of 5 times 10. So that would be the log of 50. So as you can see, both of these equations are identical, say for the x and the 50. So we can just cancel out these two. So then the answer is x equals 50. Last question. The log at base 3 of x equals the log of 18 minus the log of 3. So in this case, it would be the log x equals the log of 18 divided by 3. So that would be the log of 6. So we cancel them out. So it equals x equals 6. And for both of them, you can check. As for, in this case, we would have to use the other method since we can't add the log. So we can say that the log of 50 divided by the log of 2 is equal to this. So then we can also say that since this also equals 50, they're the exact same. I don't really know why I just did that right now. That's fine. So I hope you enjoyed my lesson on laws of logarithms, and have a nice day.